Okay, so this lesson is on proving triangle similarity by side, 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 and side, angle, side. Remember, these are two things that we learned before when we were proving congruency, but we're going to use the same type of thing now for proving similarity. So that's the difference between it. So we're going to learn how to use the side, side, side similarity theorem and the side, angle, side similarity theorem. And we're going to use slope. If you recall slope would be y1 minus y2 over x1 minus x2, or vice versa. It doesn't matter. And that's how you get your slope. So you're using that with 2 points. So the side, side, side similarity theorem, in order for things to be similar, they do need to be proportional. This is the key word here. And then the triangles are similar. The same angle measurements all the way around, but the sides are actually proportional, which means that this proportion, when you take this fraction and this fraction, are going to be exactly the same. Now the side, angle, side similarity, the angles are congruent and the lengths are proportional. So you have congruent angles and proportional lengths. Congruent angles, proportional lengths. So it's basically the same thing we've done in the past, just a little twist on it. And if you're looking at this triangle right here and trying to figure out which one of these is similar, you're going to set up a proportion to find that out. So you're going to do 5 over 2.5, and I'm going to use that same one for both of these. So 5 over 2.5, 5 over 2.5. I'm going to do one for this one and one for this one. Now this one's going to be 7 over 4. So 7 over 4. If I cross multiply this and it's the same, these are similar triangles. And then I can write a similarity statement. If they're not, they are not similar. So cross multiply, and you're going to get obviously 20, but then you get 17.5. Well, not equal, so therefore, no, not similar. Okay, on this one, same thing, I use the same thing, the 5 and the 2.5, and I'm going to use the 2 and the 1. So 1 and 2. Cross multiply, you get 5, you get 5. Yes, we have a match. These are similar. So triangle ABC is similar to triangle, and I went up and over, so to triangle TRS. Did I do that right? 2.5 ABC. So I did do the long side first. Okay, so RST. And you're done. So when you're determining similarity or similar triangles and similarity between two triangles, you just need to cross multiply. And if it's the same answer, they're similar, but if it's different, they're not. Okay, find the value of x that makes these two similar. So I can't just throw any old thing in there, right? I actually need to figure that out. Well, if they're saying that EF is similar to XY, or sorry, XZ, nope, take that back again, YZ, then that's what I set equal to each other. So 2x minus 1 equals 14. And once you finish solving, you can see that that's the value of x that would make these similar. Similarly, you could do 5x plus 2 equals 11. But if you set this up like this, you are not actually figuring out how they're similar for the value of x that would make that work. So I can subtract 2 and divide by 5. So subtract 2, you get 9, divide by 5, that's 9/5. Add 1, that's 15, so you get 15 halves. 15 halves is not equal to 9/5. And you can see right away that's not going to work for you. So This is basically what we do not want to do. So in the past, that's what we've done, but when in similar triangles, you are going to set up a proportion and solve it that way. So you get 5 over 10. And if you're wondering where I got it right here, is equal to 11 over 5x plus 2. And then you can actually solve for x that way. So 5 times 5x plus 2, so 5 times 5x plus 2. Don't forget to distribute. So you get 25x plus 10 is equal to 110, and therefore x is equal to 4. Now once you're done solving that, you can plug it back in if you'd like, and then you'll get your answers for that. So 2 times 4 minus 1, 2 times 4 minus 1 is 7. 7 over 14 is 1/2. So it worked for the other one too. And then this one would be 22 if you plug it in. So you can see 1/2, 1/2, and 1/2. So if you set up a proportion, that's how you're going to solve it. Don't do this because they're not saying they're congruent. They're saying that they're similar, which is different than congruency because it means not equal. So if you are verifying congruency, you can see this is RS and XY, those go together. So all I got to do to figure out what the proportion value is here, or the ratio is simplify. And you can do any one of these you want. So this is your fraction here, your fraction, 15 over 35, 3/7, 24 over 56, 3/7. Looks to me like my ratio between the two is going to be 3/7. The shortest side of a triangle that's similar to this is 15 units long. So the shortest side, so that means it's going to match up with the shortest side here. So 15 over 6, find the other side lengths of the triangle, 15 over 6, and I'm going to find this side, 7, and I'm going to find this side with the 9. And it'll give me the other two lengths of the triangle. So you get 17.5 and 22.5. So 17.5 and 22.5. And the triangle that's similar to this triangle with the shortest length being 15 units, which again matches up with the shortest length here. These are the lengths of the other triangle. The longest side of the triangle is 6 units long. So the longest side on this one is right here. That is the longest side. So 6 over 9. And I want to solve for this side. So that's going to equal, sorry, I should have put the equal in orange, didn't get matched. But this is going to equal 36 divided by, so x equals 4. And then this side, 6 over 9 again. And remember the 9 came from this triangle, so the 7 is going to go down here. And x is going to equal 4 2/3. Okay, just a couple more examples, should be quick ones. So you're building a lean-to shelter, which basically means you go under it and you have shelter. From a tree branch is shown. Can you construct the right end so it's similar to the left end using the angle measures and lengths shown? Well, if you do 10 over 15 and set that equal to 6 over 9, yes, because triangles are similar. So I use this measurement here, 10 and 15, and then 6 and 9. So you can see this triangle and this triangle. Actually, the 10 goes here. And you can see the 2 triangles here on the ends. I'm going to shade them in real quick so you can see which ones I'm talking about. Okay? All right. Moving on. So, explain how you can show that the indicated triangles are similar. Set up a proportion, cross multiply. So 24 over 28 equal to 18 over 21. We don't know. But if you cross multiply, you will get 504 and 504. So yes, they are similar. So on the same token, you can do the exact same thing here. And you have XZW, this triangle right here, and YZX, this triangle right here. So are they similar? Well, I can take XW, which matches up with YX. So YX, XW, so 20 over 15. And I can set that equal to XZ for both of them, right? So 12 over 12. So if you cross multiply, you will get ZX. Nope, sorry, that was to YZ. I was like, something's not right here. So this one actually goes to YZ. So it is 20 over 15 and 16 over 12. Yeah, that's better. So match those up, because these are the 2 that match up that I just talked about. WZ matches up with ZX right here. So I had to compare the 2 triangles. Okay, so then cross multiply. You're going to get 240 and 240. So yes, and you're good to go. So this isn't something that's used very often, but if you're using proving slope criteria to use similar triangles, you can find the slope of one, the slope of the other. If 2 non-vertical lines are parallel, they have the same slope. And if 2 non-vertical lines have the same slope, they're parallel. So it's true either way. This is for parallel, and this is for perpendicular. So same thing. Again, not used very often. I don't even think I put it in your homework because it's one of those things that, oh, that's good to know, but you're not really going to use it much. Okay. Thanks for listening, and hopefully you got something out of this. If you have any questions, please let me know.